Okay, the next presentation is from Eric Murray, who is a senior network engineer over at Kindred Healthcare. Come on up, Eric. Clicker.
Good morning, everyone. What I hope to present to you today is kind of a view from a large enterprise, or a large healthcare enterprise, is some of the challenges and the technical complications that we face, throughout on a day-to-day basis. We're a company that has grown through acquisition, so we do a lot of acquisitions, integrating different systems, so we're all the time having to create new solutions and face different challenges and problems to overcome. So a little bit about Kindred Healthcare. We're a top 150 private employer, 77,000 employees, revenues of $6 billion. We have over 2,000 locations in 46 states across the United States. So what I'm showing here is a slide basically that kind of describes several different lines of businesses that we have and how these lines of businesses have different types of requirements and different needs for our network. Our hospital lines of division, they have larger connections, typically do a lot of video conference. They're using a variety of applications throughout our central data center infrastructure. So they also have like centralized billing offices, so they do a lot of communication through the MPLS network to these centralized billing offices. They have other needs for like radiology, sending large images. So we have more bandwidth and a need for QoS designed around those types of applications in those facilities. Our nursing center line of business has much thinner margins, so they typically have a very small connection, although they still use some video conferencing. And one of the things that's really important for our nursing center line of business is Wi-Fi. And this is due to clinical applications that we're running on mobile platforms. So there has been a real push lately for seamless wireless full coverage in all of the facilities. And then we have our rehab line of business, which is about 1,200 of our locations that rely a lot on cheap connectivity. These are typically very small sites with a lot of times in small hosted facility where we're providing connection with DSL or 3G, and they're using maybe one wireless access point, some mobile platforms, as well as maybe a PC. Some of the operational challenges that we face are that we have limited amount of network staff to support these sites. The configuration differences between these different types of lines of businesses for these facilities presents some challenges for first level and NOC to support, because there are so many different application requirements or special configurations across all these locations and to enable that to work. There's always like a gap for support. So even our engineers, upper levels of support, are having to work a lot of first level type support issues, just because our first level support staff in our operations control center don't have the knowledge or to get through some of these configuration differences that aren't necessarily documented very well. The different lines of businesses also have different requirements for the applications, which causes complication in standardization. And this is also, like, you can see this in like the hardware refresh cycles for these types of facilities. So we start implementing something like WAN acceleration to deal with radiology traffic or something like that. And then we roll this out to a number of sites one year, and then the following year that equipment is now upgraded to another model of equipment, a later model of equipment. So even within the same lines of business and the same requirements, we have a large number of different platforms that have just naturally occurred through the evolution of the hardware. Wireless support is really outpacing our abilities to keep up with it. With so many mobile platforms, and we have like one wireless engineer, we've gone to a controller-based platform, but over 75% of our service tickets and service calls revolve around wireless and mobility, and a lot of our medical applications use this. So it's pretty important. Another thing that has really caused us a lot of problems is the expectation for public Wi-Fi or hotspot access in our facilities. So our customers and their families desire to have this wireless Wi-Fi access, and something that started off very small was just adding a little bit of internet access to maybe a few hospitals that was even done by local hospital administration. Now it's expected to be supported with commercial grade service for these facilities. And this can be very difficult because we're not going to backhaul all the internet traffic over the WAN because it's cost prohibitive and is expensive for the business and the business model that we're in. However, direct internet access at the local facility is very difficult to maintain, troubleshoot, and keep our hands on. Implementing newer technologies is very expensive and cost prohibitive as well, because now whenever we want to do something like WAN acceleration, we have to go out and buy an appliance or buy a card to fit into a router. It's just one example. Now, this takes the facility down, it interrupts user traffic and operations, so there's a cost even beyond just the capital expenditure for the hardware. And the requirements are also evolving continuously. With the regulations, HIPAA compliance, new clinical applications, there's always a push from the business that drives a lot of change on our network. In a medical environment, many times, the applications also have to live for a long period of time. So we have a lot of applications on our network running on, Unix-based systems or other platforms that have been around for 15 or 20 years. What I'm going to talk about now is kind of like a case study acquisition example, and what I hope to get the point across with this is just how a simple task of connecting and integrating two businesses into one has a lot of complexities, a lot of management points, and can introduce a lot of technical challenges for our engineers. So in this example, let me just outline that acquisitions at Kindred Healthcare are kept very quiet. So a lot of times the technical staff does not even have the opportunity to do discovery or even kind of look and see what the problems are, or have a lot of time to develop solutions for this. So the scenario we're going to talk about is Corp 1, which would be Kindred Healthcare. We have 800 locations on our network with a variety of platforms. Corp 2 has undergone 3 acquisitions previously, so a lot of their systems are not well integrated. They have 2 different data centers and 1,200 locations. And the business has dictated to us that we have like 90 days to migrate these data centers and these facilities onto our platforms in order to achieve synergies that they need for financial reasons for the business. So we don't have a lot of time to pull this off. So these slides here I'll show kind of like what we went through. So we have these 2 companies, 3 different MPLS networks from 3 different providers. So we add a basic 4th MPLS network, not necessarily the ideal design and from an engineering perspective, but again, due to the secrecy of the acquisitions, a lot of times these connections are actually ordered by management, upper management, and so we don't have a lot of input on the design. So we have to work with what we have and come up with a solution for that. And so this connectivity is established for day 1 activities, and this presents some challenges in that we have to put in a lot of route maps, do a lot of redistribution, and to control feedback, routing loops, etc. And so on these slides, I'll kind of show just like the little dots kind of just show like all the little touch points of where there's complexity and configuration. So then we have to put in configuration to address overlapping networks. There are a lot of, with 42 locations on their MPLS network, as well as 2 different data centers and a lot of different VLANs, there's obviously going to be a lot of IP address conflict. So then we put in the NAT to handle that. Then the next challenge is that we have to provide connectivity to actually migrate the data centers and all the data from their data centers to ours without impacting day-to-day operations or the user traffic. So we put in 2 additional links, point-to-point links, and in order to separate the traffic, we have to use the source-based routing and to control the DC migration traffic. Now, Corporation 2 is also a very risky environment. They have not had any kind of controlled internet access. Many of their systems are not well maintained or virus patched. So they have a known number of virus infections and instability in their network. So we have to use access lists to maintain, to mitigate that threat. This also presents a challenge in that as the applications teams are trying to get interfaces to talk, financial systems to talk, and other medical applications to talk, then they have to constantly come to us, a lot of times without even knowing the requirements, and ask us to open this access up. So this can add delay and complication and just in the process of trying to get things done. So what we did is we actually put our virtual server platforms in these locations. They have a number of physical servers. They weren't virtualized at all. It's a very unstable environment. And then we put our virtual platforms and our storage in these locations and virtualize all of their servers, which I believe in one data center was about 200 servers. The other data center was about 300 servers, so about 500 servers total. And we did this in about 30 days. So we put our virtual platforms in and virtualized their entire environment. It would make it a lot more stable and give us a platform to migrate this. Then the SAN is replicated to our environment using the links that we set up to migrate the traffic. So then what we do is we have to keep the IP addressing the same for these servers because the knowledge base has left the building. All of the people who design these applications in the legacy environment no longer are there, and we don't quite understand what will break when we change all these IP addresses or try to move these servers. So we pick them up and move them as is, an entire subnet at a time. We moved both data centers over 2 nights. We moved one data center one night and the second data center the second night. That's 500 servers we moved across a 100 meg link in one evening. So we moved the policy-based routing and the routing redistribution. We moved that back over to Corp 1, as well as moved the VLANs and the segments over to Corp 1. And now all the VMs are spun back up in that short time window, and they're moved. And then we had to do the same thing with the remote sites. So the remote sites also have IP address conflicting, and our client systems teams and our implementations teams at all these 42 locations, as well as the large number of rehab sites that are using internet connectivity, don't have time to go out and re-IP address everything and replace all the equipment. So keeping in line with the short time frame that we have to move this stuff over, we decide to just use some creative engineering to move these sites over and keep the IP addressing and basically intact. So what we came up with is we use GRE tunnels, and policy-based routing to send the legacy traffic over the GRE tunnels through to Corp 1's router behind our translation, the network address translation tables on the migration router. So as you can see, this adds a lot of detail of complexity here, this slide. The GRE tunnels come up through Corp 1 router behind the NAT translation, and we were able to move those virtual servers over onto our platforms by trunking that over .1Q through our core and into our virtual infrastructure. But again, now we have this separate routed environment out there where we have to maintain all the NAT translation, the access list, the policy-based routing, and the trunking down to our core. So this is kind of a summary of the challenges using that method. You know, every hop on the network has to have special configuration applied, NAT, redistribution, access lists, and policies to control the routing. A large number of locations, in this case it was 42 different hospitals, also had to have very specific configurations, VLANing, source-based routing, and policies to send the traffic over the GRE tunnels. And with a limited support staff, we have 8 network engineers to support all of these 2,000 locations on our network. That is very difficult for a lot of people to come up to speed, when supporting this or troubleshooting this after it's been implemented. So, with all that being said, hopefully I kind of showed like a little bit of complexity, just one example of many of the things that we deal with. We do these types of acquisitions 3 or 4 times a year. This example was a fairly large one that I've showed. but we're always acquiring little healthcare companies and businesses throughout the United States, and we have faced many challenges that we have to overcome. So how can SDN help? Once the network is defined in software, it can be much easier to manage and scale. I hope that you guys can help us come up with solutions that will enable us to define network through policies, profiles, or centralized configurations that we can push out to the network. We've seen this in other examples of IT, and it's been brought up here at the conference, with the abstraction of hardware at the server level, with the controller-based wireless technologies and virtualization. I think that we have to get the network to catch up to that point. Using these policies and procedures can enable us to have better control of traffic when enabling interfaces to other applications or vendors or other medical communities. Many times we set up VPNs to doctors' offices for radiology, and we would like to be able to do this in software where we can control the access based on a per flow type basis. I think that would be a lot easier to manage and secure. Then the new features like if we have new requirements for WAN acceleration or radiology or some kind of flow optimization, that we can enable that through software instead of having to purchase hardware or appliances or modules to fit into our routers. It should be a lot easier for us to do that rather than have to go through multi-year projects that cost hundreds of thousands or millions of dollars to roll out with a disruption to the users. And we hope that software-defined networking can increase the consistency and user experience of our mobile clients. We see the mobile space booming in our industry. I mean, we have 50,000 handheld devices using wireless right now out in the field, with clinicians roaming from room to room or from location to location. And when these TCP-based connections break, when they move through a dead spot in wireless coverage, or their profile from one wireless facility doesn't quite match the profile from another wireless facility, it creates a lot of support that we have to deal with. And so that brings to this last slide, how SDN can enable better workload mobility and a higher level of redundancy and a better overall user experience. And conflicts can be easier to deal with, such as the example that I have shown with VPNs and NAT translations and policy-based routing. And many of these things, if they're dealt with in software, can be easier for a small number of people to manage. And additionally, network provisioning is also one of our big problems. We have to have our best network engineers configure this equipment and send it out to the facilities because it's so complex. If we can do this through software, through policies and profiles, and push that config out, then maybe we can have contractors, vendors, or even less skilled workers to do that for us. So this last slide kind of shows like the phenomena of what we see in the ability of the availability of skilled workers in our environment. So we're always looking for good network engineers, and as the complexity of networking keeps going up and networks keep getting larger and larger, what we're seeing is that the availability of highly skilled engineers is going down. So now you must become very, very specialized in one discipline of networking. You have to be a wireless network engineer. You have to be an expert on VPNs and firewalls. Gone is the days of the network generalist. And these people are getting harder and harder to find. And as the networks keep getting more and more complex, we see this is holding especially true for us. Right now we've been looking for a good wireless engineer for 6 months. We haven't found one yet. We need one to complement the one that we have. Hopefully, software-defined networking can help fill this gap for us and kind of bridge this phenomena of complexity and skill within our environment. That's all I have. I appreciate your time.
Would you like to take a question or two?
Sure.
Yeah. One or two questions?
Yeah.
Yes,
so,
please.
You said that 75% of wireless of tickets come from wireless, right?
That's correct.
Can you maybe quantify within the 75% what are the types of tickets that you are seeing and what is the split?
The types of tickets we've seen range everything from a wireless clients not associating to an AP due to possibly the AP having a hardware failure, or the clients having an issue with the profile. We see tickets based on interference. Sometimes it's user issues. Sometimes it's a circuit issue with the DSL provider. Some of these smaller sites where we have DSL and just a wireless AP and a firewall sitting there. So it's a little bit more difficult to troubleshoot for first level support. I think a lot of these on wired clients would be caught by first level support, but because the first level support can't really see into the wireless infrastructure as well as they can, using traditional tools, it makes it more difficult, and the tickets have a tendency to float up through the IT staff.
Yes, one last one.
Yeah. Hi. I have a clarification question and then a follow-up based on that. When you talked about the explosion of wireless endpoints in your networks,
yes.
Did you primarily mean wireless as in Wi-Fi endpoints, or also 3G or 4G cellular devices?
Mostly just the Wi-Fi. We do use 3G technology just to get broadband connectivity in some hard-to-reach places. But yes, let me clarify, that's Wi-Fi access.
Okay. And then follow-up to that is that, do you see also growth in devices that are data producing and not just data consuming? So for example, connected devices that are producing data like maybe radiology data or image data or video data that need to access these VMs and have mobility concerns in that area?
Yes, we're kind of on that horizon now, actually, as we speak. There has already been kind of a push and a directive from management that we need to try to figure out how to allow YouTube, of all things, out to all these facilities for training purposes, which obviously that creates a large headache for us network engineers. With so many locations and so many users, we don't want YouTube taking down our entire network, right? So, these are some of the challenges that we face. So, yeah, video is becoming very big. And then also that we have another case where they want to have doctors' offices. Instead of having the doctors actually go see the patients, they want to be able to use a wireless, like a computer on wheels with a video conference screen, and have the doctor sit at his office and wheel this platform around to different patients to see the patients. So yeah, we're constantly coming up with new requirements. The business is always coming up with new ideas, and in Kindred Healthcare is very aggressive in pursuing new technologies to enable us to provide better healthcare.
All within the auspices of the umbrella Wi-Fi network that you have?
Yes.
Okay.
Yeah.
Okay. Thank you.
Excellent, Eric. Thank you so much. Great job.
Thanks.
Good.